Hi class, let's take a look at this problem here. We have three randomly selected households and the number of people in the households are 2, 4, and 9. Assume we take a sample of 2 from this group and we sample with replacement. Listed below are the 9 different combinations. So I can have 2, 2, 2, 4, 2, 9, 4, 2, 4, 2, 4, 9, 9, 2, 9, 4, 9, 9. These are all the combinations. So in essence, what I want to do is I want to create a frequency distribution based on the variances. Okay. So what I've done here is I've created the different combinations, and I actually did standard deviation, but let's go ahead and type in variance. I have to do this in Excel, by the way. I can't do this in StatCrunch. And I want the var.s function, okay, because this is a sample. So there's my variance there, and then copy this down, and here are my variances, okay? Now note that I have some repeated variances here. I have 0 3 times, I have 12.5 a couple of times, 24.5, and 2. So let's go through and let's actually populate my frequency distribution here based on these results. So the first one is going to be 0, and I had 3 responses that were 0 out of a total of 9. So that's 3 divided by 9. Then the next response is 2, okay, numerically speaking, and I had 2 responses that were 2. So 2 divided by 9. The next response was 12.5, and as you can see, I had 2 responses that were 12.5, so again, that's 2 divided by 9. And then finally, 24.5, and I had 2 responses that were 24.5, so again, 2 over 9. Make sure that all these probabilities sum to exactly 1. If they do not, then this is not a valid probability distribution. Now, they say compare the population variance to the mean of the sample variances. So what does that mean? It means that I have to take the values 2, 4, and 9, 9, and find the population variance. So var.p for population variance of these results here, and that gives me a population variance of 8.66. Now compare that to the mean of the sample variances. So how do I do that? Well, I have to come over here and type in the sample variances just as they appear in my table and their corresponding probabilities in this column here, 2 divided by 9, okay? And now what I'm going to do is I'm going to do an expected value calculation where I multiply each value times its corresponding probability, and then I sum those results. So let's sum these results right here. There they are. And as you can see, lo and behold, okay, the mean of the sample variances is the same as the population variance. So the population variance is equal to the mean of the sample variances. A is the correct choice. Thank you. Hold on, there's more. Excuse me, there's more. Do the sample variances target the value of the population variance? In general, do sample variances make good estimators for population variances? Well, the answer is yes, they do. Okay, why? Because the previous response, okay, is what satisfies the condition to make this requirement affirmative. In other words, the population variance is the same as the mean of the sample variances. The same thing is true for mean. The population mean is the same as the mean of the sample means. Okay? The same thing is true of the proportion. The population proportion is the same as the mean of the sample proportions. Okay? Mean, proportion, and variance are what we call unbiased estimators. And they are unbiased because this condition right here is true. The population of the parameter is the mean of the sample parameter. If that statement is true, then it is considered to be a good estimator for the population parameter. Okay? So in this situation, the sample variances target, therefore the sample variances make good estimates. So I would say, let's see here. I would say B is going to be my best choice here. And indeed, that is correct. Thank you.